Let's see how to generate ROC charts with R. So here again we are using the same data set that I was using in the earlier lecture. So we read it by doing this. This is the file ROC example small.csv. So the package that allows us to generate ROC charts, one package that allows us to generate ROC charts is a package called ROCR. For obvious reasons, it's ROC in R. And it's all in uppercase. So that's how you install the package. Once you install it, of course, as always, you load it with the library command, library ROCR. Okay, so now that that is done, this is the data set. Now, I'm assuming, of course, that this is our test partition, if you like, and we are not looking at the process by which the probabilities have been generated. Somebody has already developed the model and created these probabilities. So we are not worried about all of that. So we are doing table.dollar class, and that tells us that there are 5 zeros and 5 ones. Okay, so that's this class is the column. If you do a table of the column, it tells you how many values of each, how many counts of each value are there. So it's telling us that there are 5 zeros and 5 ones. Okay, as I've already said before, we are treating the class 1 as our positive class. So all of these probabilities correspond to the probability of something being a 1. Okay, so now that we are going to use R to do our ROC charts, we don't need to worry about sorting it by probability, looking at each value, etc. Right? I did that in the previous example just to show you what the ROC chart actually means. Okay, so the first thing you do with ROC, again, this you'll just do it mechanically, is to generate what is called as a prediction object. Okay, so we use the function prediction from ROCR. In fact, in ROCR, we use only 3 functions. Okay, and all the time we'll be using the same 3 functions. Okay, so we are saying take the probability column from the data set and take the actual column, the column that contains the actual values. Okay, so the first argument to the prediction function is the column that contains the probabilities. The second argument is the column that contains the actual classification within the data frame. Okay, so we pass both of these, and in our case, the class labels are numeric, right? Then the highest value is treated as the positive class automatically. So in our case, the 2 values are 0 and 1, and therefore 1 is going to be treated as the positive class. If you want to change the positive class to something else, you can do that, and I show that later in this demonstration. Okay, so the next thing you do once you have created the prediction object, right, there's no need for us to go any further into this particular function, right? So you call the prediction function, you pass the probability as the first argument, the actual class as the second argument. Okay, and it'll generate the prediction object. You don't need to worry about what the prediction object contains. All you have to do next is to call the performance function and create a performance object, right? So in the performance function, all you have to do is to pass the prediction object, which you just created earlier. And for generating an ROC chart, we just want to indicate the 2 things that we are going to be plotting, the true positive rate and the false positive rate. So you just give it as TPR and FPR within quotes. Okay, now the performance function is capable of generating many other kinds of things with related to ROC charts. But in this course, we are only interested in generating ROC charts. So this is all we have to do TPR, FPR as it is. Okay, so in fact, this line will always be the same for you. Okay, it's only in this line that these arguments may change because you have to give the name of the column that contains the probabilities and the name of the column that contains the actual class, and that will change from data set to data set. But once you've created the prediction object, stored it in a variable called pred, this line is going to be always the same. Once you do this, all you have to do is to do plot perf, and out comes your ROC chart, except that the diagonal line is missing. And we can plot the diagonal line by doing this piece of code, right? Once again, You can just mechanically use this piece of code. All that is saying is the power object contains all your plotting parameters, okay, and basically the lower bottom left and the top right are contained in these locations. Okay, so you've got this. Once you do that, you get this line as well. That's your ROC chart. Okay, so you can plot. Normally the ROC chart, since we've got only 10 rows, the chart looks very choppy. But normally when you have, let's say, 1,000 rows or 2,000 rows or even 100,000 rows, then you will see that the ROC chart is sort of a little more smooth. Okay, and the point of the ROC chart, of course, is to identify the point that is furthest away vertically from this line and use that as a guide to selecting the trade-off. Okay, so in this case, we see that, of course, we know from our prior example that here we identify 4 of the of the positive cases while not incurring any of the negative cases. So we may want the cutoff corresponding to that point, which is basically 0 and 0.8. Okay, so how do you select the cutoff? The way to do that is to again generate this object called prob.cuts, and essentially what that object basically is this thing that we looked at earlier. It's this, okay, the probability and the false positive and the corresponding true positive rate. Okay, so that's exactly the data frame that we are creating with prob.cuts. Okay, so saying cut is perf, this thing, this is the cutoff probability, and this is the false positive and the true positive corresponding to that cutoff probability. Okay, so once you do that, you can print out this data frame. This is, after all, a data frame. We're creating a data frame. You can print it out, or of course you can view it in the viewer, and you can now say, okay, what true positive rate do we want and how much false positive are we willing to tolerate? Okay, so as you see here, you're going down, the true positive increases, the false positive also increases. Ideally, the true positive should increase at a much faster, much more rapid rate than the false positive. So in this case, you can see the true positive has come all the way up to 0.8 and the false positive is still at 0. Okay, so let's assume that that's what you want, right? That you find that this point to be a very good point, that you've got 80% of your true positives without incurring any false positive. And to get the remaining 20% of the true positives, you have to incur 0.6 of the false positive, 60% of the false positive before you get the final 20%. You may say, well, I don't want that. That's too costly for me, let's say. Okay, so this is the point we want, and therefore we will choose the cutoff of 0.596. Okay, so essentially that's what you have to do. Find out which true positive, false positive combination is good for you and choose the corresponding cutoff. Okay, in this example that we considered, our classes, the class labels were 0 and 1. And 1 was the positive class. And we said that that is the default, right? So we didn't actually have to anywhere say that 1 is the positive class, right? Now, what if, for example, in this case, 0 was actually the positive class, right? In which case, we don't want the system to take 1 as the positive class by default. So we have to tell the system, no, 0 is my positive class. Okay. Similarly, what if your class labels are not numbers, but they're words like buyer, non-buyer? Then also we have to explicitly tell the system which is the positive class. So let's understand how to do that. Okay, so here's an example called ROC example2.csv. In this, the class labels are buyer and non-buyer. Okay, and we want buyer to be our positive class. So the way you specify that is when you create your pred object, prediction object, say dat $prob, that's the name of the probability column in this particular data frame, and dat $class, the name of the class. This is just the column names, prob and class are as they are. And here's where we are explicitly specifying which is the positive class. We're saying label.ordering in this class column. The labels are non-buyer and buyer. And we are saying specifically the ordering of the labels is non-buyer, buyer. By putting non-buyer first and buyer second, we are telling the system that buyer is the positive class, non-buyer is the negative class. Okay, so that is how you explicitly specify it, by using the label.ordering argument and supplying a vector in which the last item you put in is the positive class. Okay, so the last item is the positive class. After that, everything is like before: performance, then plot performance, and then the lines to draw the 45-degree line, and here you go, you get your ROC chart. Okay, and again, you can find out which point you like. So for example, here you might choose this point as your furthest point away from this line, because up to this point you're getting a rapid increase in the true positive rate. Beyond this point, you can see that it's tapering off. In order to get every additional true positive, you have to incur a lot of false negatives. Okay, so you might choose this as your favorable cutoff point. So what you will do then is, you will, like I did before, you will generate the data frame containing the cutoff point, the cutoff probability, and the corresponding true and positive, true positive and false positive rates, and you'll choose the corresponding cutoff. Okay, you'll choose the corresponding cutoff probability corresponding to that point, which looks roughly like, something a little 0.2 and 0.85, something like that. Okay, so what you have to do is, to generate this object, the prob.cuts, you'll execute this line of code exactly like this. No need to change anything. And then you'll go and examine that prob.cuts, and from there you will go and find the TPR FPR combination and look at the corresponding cutoff probability and use that as your cutoff. Okay, so that concludes our discussion of some of the important concepts in classification models, as well as evaluating classification models. Starting from the next lesson onwards, we'll start looking at actual classification techniques.